Hello, welcome to this lesson of our study of calculus 1. So in this lesson we just go through the domain of a function. Okay, already we discussed about what a function is and types of functions. Okay, so if you have not subscribed to the channel, kindly subscribe to support the channel as well. Okay, so domain of a function, given a function f of x, okay, then the domain of f of x is all possible, this is very important, all possible values of x, that is the independent variable that makes the function f of x defined. Okay, so let's say if I have a function like this, f of x equals, let's say, 2x minus 1, then the domain of this function will be all the possible values of this x that when I plug in here will make this function defined. Basically, domain is actually looking at values of x that will make the evaluation of the function to be in the real numbers. Okay, what I mean is that what are the values of x that when I put in this here minus 1, I'll always get a real number, and in this it means that x actually belongs to all real numbers, because all the values of all the real numbers, when I put it here I will get a real number back. It means that will be the domain. Okay, so let's go ahead and take some specific examples and work on them. So I have the first example to be here. Okay, now find the domain of the function f of x equals 1 over 1 plus 1 over 1 plus 1 over x. Okay, I hope this is very cool. Okay, 1 over 1 plus 1 over 1 plus 1 over x. And so to solve this, what you have to do is just think about it. The domain should be all the possible values of x that when I plug in here I'll get a real number. So the question is there any case or is there any situation that when I plug something in this function I'll not get a real number? That's the question you ask yourself. So let's go ahead and solve it. So the actual function is f of x is equal to 1 over 1 plus 1 over 1 plus 1 over x. Okay, now let's think about this. When x is equal to 0, what will happen? So when x is equal to 0, we'll get something like this. Okay, so when I plug in x, that is when x equals 0. Okay, since I have a fraction, that is why, and x is a denominator, that is what I'm trying to put in 0. Okay, someone may ask, why are you putting in 0? Simply because when I put in 0 in this, what will happen is it will make this side 0. Okay, this side of the function, and that is a denominator to one fraction, which is this. Okay, so it means that side of the fraction wouldn't be defined, or it will not be defined. So it means that the whole of this function will not be defined when when x is equal to 0. So when x equals 0, f of x is not defined. Okay, it's not defined. So what we can say is that for this function to be defined or to exist in the real line or real number system, or to be a real number, that is f of something should be a real number, then x shouldn't be equal to 0. Okay, that's the first case. Now what if x is equal to -1? What will happen? Let's look at this. When x equals -1, so you start like this. When x equals -1, now I'm coming to take only this part of the denominator, this part. When x equals -1, what will happen? I'll have something like 1 plus 1 over -1, and this will give me 1 plus -1, which is equal to 0. So it means that when x equals -1, the whole of the denominator of this fraction here, okay, sorry, I'm coming to erase some parts. Okay, I'll write them back, don't worry. Okay, when x equals -1, this is what you have. We've already said that it will be that part that I took, okay, this part, it will be 1 plus 1 over negative 1, which is equal to 0. And it means this part will be 0, and when it is 0, we'll get something like this. 1 over, let me write it again, 1 plus 1 over 0. Okay, and 1 over 0 is not defined as well. Okay, so when x is equal to negative 1, the function f of x is also not defined. Okay, so in that same manner, f of x is not defined. Okay, now so that for this to be defined, x shouldn't be also equal to negative 1. It shouldn't be equal to negative 1. Okay, so we are trying to look at some specific situations. Now let's go to the last one. You have f of x equals 1 over 1 plus 1 over 1 plus 1 over x. Okay, so now what will make the whole of this part? Now you know that when this denominator is 0, the function is not defined, and also when this denominator is 0, the function is also not defined. Okay, that will be when x is equal to negative 1. So you can, in other words, for the other one that we did, the second part, you can also ask yourself what will make this equal to 0. Okay, then you solve for x. So when it is actually equal to 0, it is not defined. Okay, that is what we just discussed. Because someone may ask that why is it that we just chose negative 1? That is the way you can use to find x equals negative 1. Okay, and the other part is, what if the whole of this denominator is 0? It's also not defined. Okay, because when you have a fraction and the denominator is 0, the fractional function is not defined. Okay, so what we can also see here is that, what if 1 plus, let me do it with a white pen, 1 plus 1 over 1 plus 1 over x is actually equal to 0. Okay, that is the denominator, the whole of the denominator of the function. Okay, this big denominator, what if it is equal to 0? Then it means the function wouldn't be defined. So what we can do is, we can say 1 over 1 plus 1 over x should be equal to negative 1. Okay, then I reciprocate it, or in other words, I can cross multiply and get something like this. 1 is equal to negative 1 into 1 plus 1 over x. Okay, so if I divide through by negative 1, I get negative 1 equals 1 plus 1 over x. So negative 2 is equal to 1 plus, 1 over x. Okay, now with this, let me divide it here. With this, you can see that if I reciprocate them, or if I cross multiply, I get negative 2x is equal to 1, s is equal to negative half. So for this, the whole of the denominator to be equal to 0, s should be equal to what? Negative half. It means that when s is equal to negative half, what will happen? So let's try and see. When x is equal to negative half, now I'll get something like this. The denominator will be this. This is equal to 1 plus 1 over 1 plus 1 over negative half. Okay, so I have this, and this, since I have 1 plus 1 over, is it? Yeah, okay. 1 minus 2. That is what this fraction will give us. So we have 1 plus 1 over negative 1, and this will be 1 minus 1, which is 0. Okay, so it means that when x is equal to negative half, the whole of the denominator will also be equal to 0. So simply, x shouldn't be equal to negative half. Other than that, we'll get 0. So x should not be equal to negative half. Now we are coming to state the denominator, the domain. So the domain is this. This is how we state it. Domain is x, okay, is such that s belongs to all real numbers, except, so with all the specific conditions, when x, except when s equals negative 1, negative half, and 0. Okay, so accept all these three numbers. That will make the function undefined. Okay, so we are done with the domain question. Now you go to the second one. This is also very, very simple, but then difficult. You have to analyze it like we did for the first one. Okay, now so to solve this, let me go and write it on a different slide. You have f of x being equal to 7 minus square root of s squared minus 9 over square root of 25 minus s squared. So in the first place, for a fractional function, for it to be defined, the denominator shouldn't be equal to 0. Okay, so this should never be equal to 0. That's the first thing we can say. So it means that 25 minus s squared should never be equal to 0. I square both sides, is what I will get. It's an equal sign, but it's just not equal to. Okay, so it shouldn't be equal to 0. I have negative s squared shouldn't be equal to negative 25. Then s squared shouldn't be equal to 25. So it means s shouldn't be equal to negative 5 or 5. So it means you can say plus or minus 5. Other than that, we'll get the denominator to be 0, which will make the function undefined. So in the first place, for us to get s values that will make this function defined, the first thing, since this is a fraction, the denominator shouldn't be 0. And the denominator is 0 when you have x equals negative 5 and 5. So the first exception is x shouldn't be negative 5 or 5. Okay. Now let's move on to the second one. That's a fractional one. So for a square root, then we go to the top one. Okay, because we have a square root here and a square root here. For the numerator, square root of what? S squared minus 9. Okay, so this function is actually defined for only positive values and 0. Okay, I hope you understand the square root. So for this to be how do I call it, defined, okay, the square root of s squared minus 9 should never be equal to, or should never be less than, or how do I call it, let me see, there should never be less than 0. Okay, it shouldn't be less than 0. Now it means that this is what we have, or you can say that it should be greater than or equal to 0. So let me put it this way, greater than or equal to 0. Okay, for it to be defined, so I have s squared minus 9 greater than or equal to 0. Okay, so I have s squared greater than or equal to 9, so x greater than or equal to plus or minus 3. Okay, for this to be defined, x should be this, greater than or equal to plus or minus 3. Okay, I hope this is okay. Are we safe here? The question is, let's try to test and see. Okay, let's try to test and see if this is correct, or you can choose any other way. Okay, I will test and also show you a different way so that you will be able to understand. Now to test this, okay, let's pick x greater than 3 and see. When s is greater than 3, let's pick something like 3.5. Indeed, the square root of that will give us positive numbers, and we are okay. When s is equal to 3, we have square root of 0, we are okay. Now let's pick s is greater than negative 3, something like negative 2. When I put it here, I'm doomed, because negative 2 squared is 4 minus 9 is 5, negative 5, sorry, and that will give us a problem. So it means that, for this function to be defined, x should actually be greater than or equal to 3. Okay, it should be greater than or equal to 3, and also x should be less than or equal to negative 3. Now with this will work. You can also look at it and test if you want. Okay, this will also work, less than or equal to negative 3, because when you have negative 3.5, which is less than or equal to negative 3, and I put it there, it will work. Okay, we will have a square root of positive number. When s is also equal to negative 3, that will also work. Okay, so this is okay now. I hope you are okay. Now let's go ahead and look at the denominator. With that one too, we're having the square root of 25 minus s squared. Now with this, for this to be defined, the square root of this should be this shouldn't be less than, or it shouldn't be less than 0. Okay, so it should be square root of 25 minus s squared should be greater than 0. If I put greater than or equal to, it means this can be equal to 0, but we said that in our first point, we said that this shouldn't be equal to 0, so the equal to sign is not there. Okay, so I have negative s squared greater than negative 25, and I have, now let's look at this. Okay, for this is okay. Okay, and so for this, when I divide through by negative 1, I'll have x squared less than 25. Okay, I have x is less than plus or minus 5. Okay, so you think about it, whenever x is less than plus or minus 5, does it work? Yes, indeed, it works, because whenever x is greater than 5, it means I'll have 25 minus a bigger number. Okay, and that's something like 5.5. 5.5 squared is bigger than 25. Okay, so it becomes a negative, so this actually works. Okay, so x is less than plus or minus 5. Now it's some way, okay, it's some way, but we'll just figure it up. Okay, so in the first place, we have f of x. Let's write f of x back. 7 minus square root of s squared minus 9 over square root of 25 minus s squared. Okay, and in the first place, we said that for this to be defined, the denominator shouldn't be equal to 0, and that gave us that x shouldn't be equal to plus or minus 5. Okay, now for the top also to be defined, then x should be x should be greater than 3. X should be greater than 3. Okay, and x should be less than negative 3. Okay, now with the other conditions, we had x should be less than 5 and x should be less than negative 5. Now if no, x should be greater than negative 5 rather. And go to the previous one. With this, the negative shouldn't be there, because when s is less than negative 5, it means we have negative 6 or negative 5.5, which will be greater than, which when we score it will be greater than 25. Okay, so it should be there, and x should be greater than negative 5. This is how it should be. Okay, it should be like this. Okay, so in our next one, let me write it there. X should be also greater than, okay, negative 5. So now with this, let's look at it clearly. Okay, see that in the negative regions, now when s is never equal to 5, it is defined. When x is greater than 3, it is defined, but then s should be less than 2. S should be less than 5. Looking at these two conditions, and when s is less than negative 3, means negative 3.2 coming to 4, negative 4, but it shouldn't reach negative 5, because it shouldn't be equal to negative 4. It means that it should be within this range. Okay, so it means the domain is this range. Let me write the range for you. Domain is this. Okay, is x is such that x belongs to the open interval of negative 5, negative 3, then close interval, because s should be greater than or equal to this. So it should be less than or equal to that. Then union the close interval, 3, 5, open interval. So like I said, this should be so it should be like this. X should be equal to S is such that X belongs to this open interval, -5, then a closed interval, meaning -3 is part union this 3, 5, and open interval. Okay, this should be the solution, the domain for the question. Okay, so thank you, and don't forget to subscribe to my channel. Okay, all right.